Hello students, how are you all? I hope you are doing amazing. So welcome all of you at AriserTalent, and I'm your physics teacher Krina welcomes you all. So in our previous chapter, we had a discussion about the electricity. It means we have seen that charges will going to exhibit the electric parameters and they will going to make an electric field around them. Now we are going to discuss our next chapter of the physics, that is about the magnetic effect of electric current. But before starting this chapter, let me tell you some of the basic things that we have observed regarding the magnets in our day-to-day life. So let's begin the chapter here. So this is what? Have you recognized what is this? This is a train which is basically used in Japan and the other countries. India is also trying to adopt these technology, and in the next generation we will definitely having a such type of the trains. This train is actually known as maglev train. What is the name of this train? This train is our maglev train. This is our maglev train. So this is our maglev train. Now this train has been widely used in the Japan for transport facilities we have, and in the next generation we will have also this transportation system as possible in India. Now what is the concept used in this maglev train? This maglev train is named as a maglev because it is working on the magnetic effect of the electric current, because the term mag is used here. It means this train will going to work on the magnetic effect of current. Now, what is the basic principle that is involved in this train? So we have named this train as a maglev train. Actually, what happened? You have seen that if you have seen the magnets, it always consists of the two poles. You have two poles in the magnets. Suppose I am drawing a magnet. So magnet basically consists of two poles. This is a very common term you have learned about in the previous classes. So this is known as our north pole. This is our north pole, and this pole is termed as a south pole. Now what will happen if I am going to take another magnet? Suppose I am taking two magnets here. This is our magnet number 1 having north and south pole. This is our magnet number 2. Again it is having north and south pole. We have the two magnets here. Now what will happen in this case? If you are taking two magnets and you are placing them like that, opposite poles are there. There is a north, here it is south, again north, again south. So what you can see here, you can see that these two poles are opposite to each other. These poles are actually opposite to each other. If these poles are opposite to each other, it means magnets have a tendency that opposite poles will going to attract each other. So what will happen in this case? The opposite poles attract each other. There will be the attraction between the opposite poles. Now, if I am considering the another case here, suppose I am taking a magnet. This is having a north, this is having a south, and I am placing another magnet in the vicinity of the another magnet. This is south, this is north. Now, what I have done, I have just placed the magnet reversely as compared to the previous magnet. Now, you can see that these are having a like poles. These are your like poles. South and south is having a like poles. So, I can say that these are like poles. And these are having a opposite, or we can say that they are the unlike poles. Now, what will happen in case of the like poles? If you bring the like poles of a two magnet close to each other, they will going to repel definitely, because the opposite poles will repel each other. So what will happen in this case? The opposite poles will repel each other. So, one conclusion I can draw from this point that like poles repel and unlike poles attract. So, what will be the conclusion here? That like poles repel and unlike poles attract. So, this is the conclusion we can draw from here, that this is the basic property of the magnet. Now, what is the basic principle that is involved in this maglev train? You know that the maglev train actually works on the principle of repulsion. This train is working on the principle of the repulsion. Why repulsion? Because you have seen that in the track and in between the train. So, in between the train and track, if the repulsion works only works when the poles are same. It means if they are having a south-south pole or the north-north pole, they are going to repel each other, and this principle will make the train to float on the track. Otherwise, if there will be the attraction between the two components, the train will not going to run on the track. So, what is the principle involved? That in between track and train, this is our train and this is our track. So, if there is a repulsion between the train and track, only this is possible to run the train on the track. Otherwise, the train will not going to run on that track. So, this is the basic principle you have seen in your day-to-day life regarding the maglev train, and this maglev train will definitely be the next generation transport system in India too. Now, let's discuss the second example in detail, what we have provided here. See, what you have observed in this picture. Can you tell me what you will observe in this picture? You have just seen that a man is floating in the air. Is it all right? Man is floating in the air. Now, what actually happens in earlier time or in the ancient time, usually Indian sadhus, the sadhus we have, try to get these postures and they have the tendency to float in the air. So, actually they have the superpowers to do something, but the normal people like us cannot do like this. Do you do like this? Can you achieve this position that man is floating in the air? We will not able to do this. They have their inbuilt powers, due to which they have the tendency that they can float in the air like this. But normal people cannot do such activities. So, this phenomena is possible only because of the strong magnetic effect of the current. And for doing this, you are needed a very strong magnets that will going to create a very large effect of the magnetic field around it. So, what will happen here? Strong magnetic field is required. Strong magnetic field is required, and if there is a strong magnetic field, you can achieve this position, and this is known as a leviation. This is termed as a leviation. So, this is what we called it a leviation, and the ancient sadhus will have a tendency to do these effects because they have the superpowers. Now, you have heard about the floating cars. Do you know what are the floating cars? Floating cars are actually the cars that are used by the kids nowadays for in toys. So, this floating car is actually based on the magnetic effect of the current, and they have the tendency to float in the air. So, floating car is also working in the same process. Now, what will be our another example? Let's see the another example here. This is a very interesting thing you have, and what is this? Let me tell you about that. Now, this material is a completely made up of magnetic material. And do you know what has its specifications, or what are the characteristics of this? When you are going to add any fluid on that metallic part, they will going to take a different shapes. You can see that how beautifully the shapes are achieved here. So, this is our fluid, and any fluid when you are taking, so the fluid have such characteristics or such qualities. When you pour the fluid in that chamber, you will get a different shapes here. So you can see that how different shapes can be achieved in this. But what is the tendency of fluid to make them so? The fluid you are using is a ferrofluid. This is a ferrofluid you have. So the ferrofluid is having a tendency that when you pour them on such a magnet, they are going to acquire different shapes here. So this is again a very beautiful explanation or very beautiful example of magnetic effect we have. So the fluid name is here the ferrofluid. Now let us see the another example of magnetic effect in our day-to-day life. Now, this is a very simple example. You all know. You all have your credit and debit cards in your pocket. So, let me show you mine. So, this is actually our credit card we have. This is credit card or debit card, any card you can take. You have seen that in that credit card or debit card, you have a stripe that is made up of the metallic part. It means your entire data will going to be stored in this magnetic part. So what actually happens here? This is our magnetic stripe. This is our magnetic stripe, and in that magnetic strip, the whole data of your account has been saved. Now, this magnetic stripe consists of a very tiny magnets. It means this is going to be formed by the uses of a very small magnets, and your entire data is stored in it. So you can see that this is again a basic application of the magnetic effect in our day-to-day life. So whenever you use your credit or debit card, you have prescribed that you don't have to destroy that magnetic strip. If you destroy this magnetic strip, then your whole data will get lost here. So this magnetic strip is actually made up of a small magnets that is going to store your data here. So you have seen that I have taken 4 examples which are from our day-to-day life, and they are working on the magnetic effect of the current. So we have a lot of examples here. So this is our few examples. Now let's start with the chapter that what is magnet. We are talking about the magnet so many times, but let us discuss here that what actually the magnet is. So let's start with the chapter here. We have seen the basic applications of magnetic effect in our day-to-day life, but first discuss about that what actually the magnet is. So firstly, we will have an idea about the magnet. Now, what is magnet? In earlier times, what actually happens, approximately in 120 AD, a black colored stone is found. And do you know where this stone is found? This stone is basically found in Greek, and in that particular region of the Greek, a country name or a state or a place name, I can say, the name of the place is Magnesia. The name of the place is Magnesia, and the black color stone that is found is termed as a lodestone. Now, what are the interesting features of that stone? That stone has the chances of attracting the piece of iron when they are kept in the close vicinity of each other. So what will happen? In earlier times, a stone is found, and that particular stone is of black color. This stone is of black color, and this stone is known as lodestone. The name of the stone is lodestone. This lodestone has a very interesting features that they can attract the piece of iron. They can attract the piece of iron. So if they have the tendency to attract the piece of iron, and it has been found in the Greek, this stone is usually found in Greek, and the name of the place where this stone is found is known as Magnesia. The name of the place is Magnesia. So the term magnet is used. So that lodestone is termed as magnet. So this is a story behind origin of the magnet. Now, what happens further? Whenever this lodestone is found, from there we have found an ore of iron, and that ore of iron is known as magnetite. We have found an ore of iron, and that ore of iron is known as magnetite. Magnetite is the name of the ore of the iron, and it is having a formula Fe3O4. This is having a formula Fe3O4. That's why the term magnet is given, because it is obtained or it is extracted from magnetite. So if it is extracted from magnetite, we have termed that compound as a magnet. So that's why the term magnet has been decided to give the name of the compound which have a tendency to attract the pieces of the iron. Now, what will happen further? This is the story behind the origin of the magnet. Now, what actually the magnet is and what is magnetism? So, let's discuss here about magnet and magnetism. Now, what is magnet? Magnet is actually a substance which has a property to attract the piece of the iron, and when you align them or when you suspend them freely, they will have a tendency to align in the north-south direction. So this is about what actually the magnet is. So magnet is a substance, it is a substance which is having tendency to attract piece of iron. So the material which a magnet can attract is not only iron, it can attract nickel and cobalt also. Nickel and cobalt too are attracted by a magnet. Now, second thing about magnet is then, when you suspend the magnet freely, it have a tendency to align in the north-south direction. So, when it is suspended freely, it aligns itself in north-south direction. So, this is the thing about the magnet we have seen here. Now, the property of a magnet to attract the piece of iron is known as magnetism. Magnet is actually the name of the substance we have, and the property to attract the piece of iron is known as magnetism. So, let's discuss the definition of magnetism here. So, what is magnetism? tendency to attract a piece of iron. The property that it will attract piece of iron is known as magnetism. So this is what the magnet and magnetism is. So just copy these definitions from here so we can proceed to the next part of the chapter. So after magnet and magnetism, let's discuss about the type of magnet we have. Let's discuss about the types of magnet. So our next topic will be about types of magnet. Now, magnets are actually classified into the two categories, that is the natural magnet and the artificial magnet. Now, what is natural magnet and artificial magnet? As the name indicates, natural magnet will be occurring naturally, and to enhance the properties, we will use alloys and some very strong materials to make the artificial magnet for our future applications. So, basically, it is of two types. It is of two types. And these two types are natural magnet and artificial magnet. First category is about natural magnet and the second one is our artificial magnet. Now, natural magnet is a magnet which will occur in nature naturally. It means it is obtained by the extraction only. So, the first category is natural magnet. Now, what is natural magnet? It means which occur naturally. So, it is basically a magnet which occur naturally. Now, what can be the examples of the natural magnet? I have told you that a black color stone has the possibility to attract the piece of iron and the name of the stone is lodestone. So, the black iron oxide, lodestone and magnetite are our naturally occurring magnets. So, examples we have lodestone, black iron oxide and third one is our Fe3O4, that is our magnetite. Second category of the magnets we have is about the artificial magnet. Now, as the name indicates, this will be made by using a very strong materials or a very good alloys. It means they are made by using alloys. So, such type of the magnets will be known as the artificial magnets, and artificial magnets are basically used to enhance the properties of the natural magnet, so it can be used for the purpose which needed a high electromagnets or the high power magnets. So, the example here will be bar magnet. Examples of artificial magnet are bar magnet, horseshoe magnet and ball-ended magnet. These are the name of the few of the magnets we have that we will see in the further chapter. So this is about the natural magnet and the artificial magnet we have. Now the magnet also have a property that it will going to exhibit two properties. The name of the first property is the directional property and the other property is known as the attractive property. So what are the two properties of the magnet? So let's discuss about the properties of the magnet. Now, what are the basic properties of the magnet? I have told you that there are the two types of properties of magnet. And what are these two types of properties? This is known as directional property and attractive property. So the name of the first property is directional property and the second property we have is attractive property. Now again, name is specifying here that what will be the directional property. Directional property means when you suspend a magnet freely in the north-south direction, it has a tendency to align only in the north-south direction. Suppose if I am taking any road and tying a rope on it and the magnet is suspended freely, then when it comes to rest, it always aligns itself in the north-south direction if you do not disturb it. So the directional property means magnet always tries to align itself in north-south direction. So this is known as its directional property. What about the attractive property? Attractional property means we can say that it's directional and we can say it attractional. This is attractional property. Attractional property means the magnet will have a tendency to attract the pieces of iron too. So it means, attractional means it has a tendency to attract pieces of iron. So this property will be known as attractive property. So the magnet basically have these two properties, that is the directional one and the attractional. Now this lecture is over for today. In this lecture, we have seen a basic description about the magnet, magnetism, its types and its property. Now, we will deal with many more topics in our next lecture, which will include the magnetic field, what are the poles of the magnet and what is the alignment processes in case of the magnet we have. So, thank you so much and have a nice day.